All right, guys, question number 15 on our intermediate test 2 review. So we have two different vectors. So we've got this guy right here, which I'm going to label A, this guy right here, which I'm going to label B. So two vectors, and if we draw in our x and y axes there, it looks like the first one hang on, the dog's going crazy. Give me 2 seconds.
I moved the hamster out of the way because it was making all kinds of noise. And like a donkey, I forgot to put the dog in its kennel. So she's barking away. So give me 2 seconds and I'll deal with this. Hey, what are you up to? You getting into trouble? I think she wants to eat the hamster. Alright, let me deal with this and we'll go back. Easy now, we'll get back to vectors. Hang on.
Okay, so as I was saying, if we redraw these guys, so I'll put in my x and y axes here. There's my y, there's my x-axis, and I'm going to draw in the first vector there. So I'll draw in my red vector, or vector A, and starting here at this point of origin here, I'm going to drop in the first vector, and it's going like that, and it has a value of 120 volts, and it's sitting right at 0 degrees. And then I'm going to take this one right here, the B vector, so that is the blue vector here, and I'm going to draw it so it is tip to tail with the previous vector. So I'm going to create like a parallelogram there. So that guy goes in here like this, and this guy would be our B vector, and it had a value again of 120 volts, but the angle here was at 330 degrees. So if I drop a line down here, then I can create a right angle triangle out of that vector there. And now we can add the first and the second one, and then we'll end up with our resultant. So our resultant we've been drawing in green, and so that guy is going to go from here to here, and that'll be our resultant voltage. Beautiful. Okay, so let's do a chart to summarize our thoughts here. So let's do the first vector. Go back to the red here, and we're going to do vector A, and we're going to do the hypotenuse, then we're going to do the angle, then we're going to do the x component, then the y component. So here we have a hypotenuse of 120 volts. The angle is 0 degrees, and so the x component for the first vector is the cos of that angle times our hypotenuse, and we know that that's going to be 120 because it's sitting right on the x-axis. And if we do the y component for that first vector, then it's going to be the sine of the angle times the hypotenuse, and so we know that that guy is going to be nothing because there's no angle. It's sitting right on the x-axis. So the hypotenuse and the adjacent are identical at this point. Okay, that will do our second vector. So next vector, guys, is we'll just label this guy B. Next vector is also 120 volts, but the angle is 330. Keep the angle at 330. And we'll see what that does to our positive and negatives. We can see here that this should be a positive x value, and because this is below the x-axis, this should be a negative y value here for the components for that vector. So for this guy, the x component for our second vector is going to be equal to the cos of that angle, so cos of 330 times 120. And here the y component for that second vector is going to be the sine of that angle times 120. So we bring up the calculator and we'll do those. All right, so cos of 330. Close brackets times 120 volts. Gives me 103.92, so that's again a positive value. And let's do the y component here. So we'll do the sine of 330. And we'll multiply that by 120. And that gives us negative 60. Beautiful. So that matches with what we predicted there. Okay. So let me just scroll up here so we can add those values up. So we'll just put a line here. And in this chart here, going down here, we're just going to add them up. So frustrating when that happens. Sorry, guys. So let's see. We've got 0 plus negative 60. So the y component for our resultant is going to be negative 60. And here for our x component, we're going to have the 120 plus the 103.92. And the reason why we're adding these up is because they're happening on the same plane. So the 120 and the 103.92, which would be right here. We can add those guys up to find this adjacent value. The opposite value over here, we found to be negative 60. Okay, so that opposite is the only opposite value in that triangle there. Okay, so adding those guys up, we got 120 plus the 103.92. That gives us 223.92. Now, what I'm going to do to find that resultant, because going back this way, we've got an adjacent value right here. So again, this is our adjacent value. This is our opposite value. So in order to find the hypotenuse, we're going to use Pythagoras. But I'm going to keep this negative out of that equation. If we look at this equation here for our resultant here, it is going to be equal to this 223.92. We're going to square that value. And then we're going to add the 60. And we're going to square that value as well. So you'll see that I kept the negative out of this equation. I find that I screwed up by putting the negative in there. Once we multiply a negative times a negative, we're going to get a positive. So by keeping that negative out of there, it is a little bit less complicated and provides us with the exact same answer as we'd have if we had put the negative in there to begin with. So let's bring this up on our calculator here. So I'm going to do the square root, and I'm going to do double brackets here of 223.92, and we're going to square that, plus bracket 60, bracket squared, and we'll do a close brackets there, equals, so I got 231.82. Now you'll notice that if you have a calculator like this where you can actually physically see what you're putting into the calculator, it helps a lot in trying to figure out exactly how you're going off the mark. Or it helps me in class to look at how you're entering it into the calculator. Possibly you're putting the square inside the bracket. Maybe you're forgetting to hit equals, maybe you're forgetting to do the square root. So it helps you to visualize what you're putting in there, and then helps me to see where you're going off the mark. So I would purchase a calculator that allows you to see the exact equation that you're putting in there. All right, so we got 231.82, guys, for our resultant. Whoa, what happened there? Hang on for a minute. So 231.82 was our resultant voltage. So you would think that 120 and 120 provides you with 240, but if they're not happening at the same time, then we have to find the vector sum of those guys. So we found the x component for each of them, the y component for each of them, and then we added these guys up because they're on the same plane. And then going back this way, we use Pythagorean theorem. Beautiful. At this point, we can now do a right angle triangle and summarize everything for this resultant here. So let's see, we have 223.92, and then we've got negative 60. So this value right here on the x-axis is 223.92. Then on our y-axis here, we've got negative 60. And for the resultant, we found 231.82. Okay, so the last thing we need to do is we need to find this angle right here. So we can use sine or cos or tan. I'm going to use cos. So here I have my adjacent. Here I've got my hypotenuse. So in order to find my angle, I'm going to do the inverse cos of my adjacent over my hypotenuse. So in that case, I'll do the inverse cos. The adjacent there is 223.92. And my hypotenuse is 231.82. Let's bring up our calculator and do that. So I'm going to do second function, cos, and I'll do 223.92 divided by 231.82. And then I'll do close brackets equals, so I've got 15 degrees as my angle. So our final answer there, if you want, we can put in negative 15 degrees, or, so why am I putting negative? So if we take a look at this resultant right here, we can see that this angle is below the x-axis here. So it is 15 degrees, but because it is below the x-axis, it's going to be minus 15 degrees. And if we take the 360 degrees, 360 minus the 15, we could also say that it's at 345, because this is our reference right here, right? So we can go from here to here, and that would be at 345 degrees. So you can give me positive 345 or negative 15 for the angle there. Beautiful. Okay, so let's just scroll out here so we can see all our values here. There we go. So you can pause it there, guys. Take a look, see if you got the same values as I have. And we'll stop her there. Next video, we'll continue on the last few questions.